So today we are still doing quadratic application stuff like we did Friday, but we're going to do it with some like real world places and kind of see if we were to do some dropping of things. Hopefully not. It could be kind of dangerous. So as we turn our page 9 here, we are still going to be dealing with our formula that deals with gravity, our -16. But you're going to notice on these, you're like, wait a minute, isn't there supposed to be a v sub 0 thing in the middle? Where is it at? What's going on with this? And the answer to that would be, since we're dropping, there is no initial velocity, okay? Whenever you see the word drop, that middle term's going to go away because it's 0. So, with these, this is the equation we're going to use for all of these. And the other good news, which is going to keep our lives simple, at least for the time being, is that the single value that's given to us on each one is going to be the S value. And you're like, well, what the heck? If it's just that, why are we even bothering? Well, let me tell you why we're still bothering. So we're seeing how long it takes for things to hit the ground. My H value is still going to be 0. This is still stuff that with repetition is getting it into your mind where you can actually use it when you need to. With this one?
No, in the picture, is that a B?
S.
No, second.
Still an S. All of them an S. All of them. And so when I go to do these, all I'm going to have to do, so I got 0 equals -16 t squared plus, and in this case, 2,684, the world's tallest man-made structure. That is really tall. It's like a half mile up in the air. That's kind of wild. And so here, we're still going to use the quadratic formula, even though I really would have options here. So I have A and I have C, since there's no, but I'm not going to need much. My B value is going to be 0. So as I'm doing this, I'm like, okay, now, if I use the quadratic formula, and you're right, with that, spacing could get to be a little bit of an issue. I'm not even going to lie. I'm noticing this now. So, here's the good news. So we got B plus or minus. Yeah, there's nothing in the middle, so we don't have a B. So we're about to learn for the rest of these, there's going to be a shortcut. Minus 4 AC all over to A. Okay, so like we have seen before, we are doing all this stuff underneath. Now, do I really need to put 0 squared in there every time? Not really. If you want to, because again, sometimes being creatures of habit, we can kind of want to go down this route. It is. I will even show. That's a good question. If I don't put 0 squared, am I going to get the same answer? Let's find out. I am. And that's always going to be 0 for these, because we're just dropping. So now I look and I'm like, hey, it's even better. 0 plus or minus. So all I'm really doing here is saying, hey, this is plus or minus 414.5 divided by 2 times -16, which is going to be the same for all these two. And so as we learned last time, with these two answers, with this plus minus, if I do 414.5 divided by negative 32, I don't think it took negative 12 seconds. That wouldn't make much sense. But it's got to be the other one. So 12.95, if we round to the nearest tenth, would be 13 seconds. So let me kind of give you a side note here. If someone were to stand at the top of this structure, let's say, and even drop a penny off of it, okay, in that 13 seconds that it would take to hit the ground, I can almost guarantee you if it would hit someone down below, it might kill them. Yes. That's how fast this is going to be going, dropping from that height. There would be a way to let me see in a bit if we can figure out how to calculate that. Yeah, I don't. We'll double check here in a minute. We'll look it up. I should have said that at the very end instead of saying it now. But for all of these, and again, Hardy, do I need to do it 12 times? Probably not. But it is kind of interesting to note, especially if at the end we work on taking a peek at this to see what the speeds would be, to kind of see how fast this would actually be going, because we'll get that done. All right, let's see how lucky we are today. Hey, 2 for 2. All right, thank you. All right, so let's play with one more. Let's play recent. Let's play closer. The Sears Tower, which isn't called the Sears Tower anymore. It is. It's the Willis Tower now. Same idea. So you're like, wait. So if we just replace that with 1730, and I'm kind of looking at this as my example. I'm like, okay, I don't have to do the 0 thing this time. I can put the 0 squared in here if I want, but I don't have to. The only thing that's changing is that last number. Like, even the denominator is the same thing still. And so I pull out my calculator. I'm a creature of habit. So we learned from the last one, the positive of this is not going to help me. The negative, though, would. So if I do negative 332 that rounds to 7. And this is still negative 32. It's going to take like 10.4 seconds for that object. They're calling it a ball, some different things, from the top to reach the bottom. So that, I don't know if we're going to be able to calculate quickly how high, if you did a bouncy ball, it would bounce back up, or if it would be going fast enough that it would just crack the surface below it and it wouldn't bounce up at all. We can look into this in a minute. We can see how quick of a velocity that's going to get us going. 10.4 seconds. Yeah, don't do that. You could get charged. That's true. Yeah, I don't want to see you on the news as being charged with injuring people because you decided to drop stuff off the top of really tall buildings. Not a good plan. Okay, so here's something a little bit new for us. I'm going to throw one twist in because it's going to help you moving forward towards your Geometry and Algebra 2 adventures. And so sometimes we're going to see these things as a graph instead of just being given an equation. And so if I did this algebraically, I've got A again. I have C again. I don't have B. So our situation with the quadratic formula from before, the opposite of B, well, there's no opposite of 0, but I'm just, again, creature of habit. B, which again, there isn't one because there is no T in the middle here. Minus 4AC all over 2A Yes, a long time ago, yes. Most of the formulas that we use in here, I memorized quite a while ago. But I've been using them a lot, too, on a regular basis. So, just saying here. All right, so we got plus or minus 64. Oops. Over negative 32. And we've mentioned it before. Even though this is plus minus, I kind of know already which one's going to work. It is. Because a positive divided by a negative, that doesn't make any sense. It's possible to have a negative initial velocity, yes. It's weird, but it's... Oh, no, not a negative time, though. So here's the thing. I used the quadratic formula. I got 2 seconds. If I were to do this graphically, you're like, well, where's that coming from? If I was to put this in my calculator, I'm going to use x, though. And I graphed it. I'm going to get a parabola. But check this out. Where does the parabola cross the x-axis? It looks a lot like 2. If I look at the chart, when y is 0, that's an x-intercept. It's crossing at 2. So wherever, if you're looking at a picture, it crosses the x-axis, that's your solution. You're going to get the same answer. So you can graphically do these, and you also can do them with the quadratic formula. So it's kind of nice. But just to make sure, I want to do one more before we go off and sidetrack here possibly into the possible injuries of dropping things off a building. You will have a b value sometimes. So I have to be aware of that. I also have to be aware that sometimes my pens don't want to work. Let's try that again. Okay. So, if I do have that, let me pull my quadratic formula back up because, I mean, gosh, what do I have the note sheet for if I'm not going to use it? The opposite of b plus or minus the square root of b squared minus 4 AC all over 2a. We got to do the whole thing this time because we have that b value. There will be no shortcuts. So again, that's going to be more of the same thing we were doing last week. Yeah. Yeah. With that b value, we're going to have to do a little more calculated now. Ooh, that came out nice. Okay. So now that we have a b value, we are going to have 2 equations to deal with. Well, let's see if we have 2 answers that make sense, or if we have 1 answer that makes sense and 1 answer that doesn't. But we do want to do the parenthesis thing. We chatted about that a lot. Negative 3. And since we're talking about time, negative any time doesn't make any sense. At least I hope that doesn't. Oops, that doesn't make any sense to you. And I get my time. Okay, so couple of reminders to throw around out there. 1, play around with these sums so you know what's happening. 2, if you need any of the notes for Unit 12 as we get ready for the quiz preview tomorrow, These notes in their entirety are on the top of Classroom, and there's still copies, blank ones, of the notes in the back if you need them. Other than that, be on the lookout on Classroom. There will be stuff coming up there to help on getting ready for the final review. So I'm going to